Okay, so this is part 3. So these are the concentrations we'll be using, correct? Now, so we talked about solubility curves. We talked about solubility curves on part 1, and we talked about the solubility in 100 grams of water on part 1. I also showed you today that that's one of the solubility quotients that you have to know. Dissolving a solid solute into water. That's most of the chapter. If it's not a solid solute, it's a gas solute. But the entire chapter is involving aqueous solutions. The entire chapter is involving aqueous solutions. Okay? So we can get rid of that. We did molarity and molality. We talked about gas versus a solid solutes, correct? So we want to look at colligative properties. Somebody look up the term colligative properties. All right, Mamuna, can you do that for me? Look up colligative properties, and then you're going to come and you're going to get that bag off the floor, right?
In the book?
Yeah, in the book, please, yes. Please. And then you're going to come up here and read that to us. I want to talk about freezing point elevation and freezing point depression. And we have a student who's going to come up and read that to me. Read that to everybody in the audience. Correct? Porv, you going to do that? You know, don't come on camera. Okay. Did you lose it? Okay, he's finding it. So let me begin by saying, when you add a solute to water, you do one of two things. You either will raise the boiling point, so the water, if I put salt in it, will boil the water at a higher temperature. It's called boiling point elevation. Or it will allow water to freeze at a lower temperature. Correct? So it's called boiling point elevation and freezing point depression. So, how many people have parents that add salt to water when they're cooking? Anybody? Yeah, and why do they do that? Do you have any idea? Mamuna. What is it? Water boils faster? No, it doesn't. No, the water does not boil faster. It boils at a higher temperature, but it doesn't boil faster. It will boil the water at a higher temperature, and it's good for seasoning. It's excellent for seasoning, but it's not going to boil it at a higher temperature. Clear? You have colligative properties? Come up here and tell us about colligative properties. Just read out the definition. Okay, we have a guest speaker today, Mamuna, and she's going to define for us something called colligative properties. Go ahead.
A colligative property is a property of solutions that depends only upon the number of solute particles, not upon their identity.
Okay, hold, just stay right there. So it's going to be a property of solutions, and it's going to be solute particles. Okay, go ahead. What else? Here, hold on to that. Don't let that fall. Okay, what else does it say?
And it does not depend upon their identity.
It doesn't depend on the identity of the particles. So you could be using sodium chloride or calcium chloride, and it's just the number of particles that are involved, correct?
Yeah.
What else?
3 important colligative properties of
All right, there are three important colligative properties of solutions. What are they, Mamuna?
Vapor pressure lowering,
Vapor pressure. Vapor pressure. What else?
freezing point depression,
Freezing point depression. And what else?
boiling point elevation.
Boiling point elevation. Is that it?
Yes.
Those are the big ones.
Yeah.
Excellent. You did very well. Thank you. Excellent. Yeah, you can sit down. Thank you very much, Mamuna. Okay? So, this is big. It's huge. These are colligative properties, are properties of solutions that depend on the solute particle. Not the type of particle, but just that it's a particle. It could be sodium chloride, it could be calcium chloride, it could be potassium nitrate, but it's just the fact that it's a particle, correct? It could be sugar. Okay? Now, so, tomorrow, or on part 4, we'll talk about freezing point and boiling point elevations and how to calculate those quantities. Clear? But just understand this. If I add a solute to water, sodium chloride, correct? It will, if I try to boil, it'll boil at a higher temperature. If I freeze it, it'll freeze at a lower temperature. So it's not going to boil at 100 degrees anymore. It's going to boil at 100 degrees plus whatever the elevation is. It's not going to freeze at 0 degrees anymore. It's going to freeze at 0 degrees, and then you have to subtract off the depression. What we calculate is the elevation. We calculate the amount that's above 100 degrees. We calculate the amount you have to subtract. We calculate the amount you subtract from 0 degrees Celsius. Clear? When we talk about boiling point elevation and freezing point depression, we talk about just water. We're not going to do anything else. And then lastly, we'll talk a little bit about how vapor pressure is affected by the addition of a solute to water. Clear? And we're off.